This walkthrough will cover fine-tuning and exporting a language model for OLlama. It is a framework that allows us to run language models locally on our hardware, making it perfect if we want to control our AI applications without relying on cloud services. We begin by installing the necessary libraries: unsloth, Monby, transformers, torch, accelerated dataset, bits and bytes, sentence piece, and OLlama Python for interacting with OLlama. We import all the libraries. We configure the environment variables. The prepare dataset functions handles loading and formatting a dataset. We load a small subset under examples of the ALPA alpaca dataset. The fine-tune model function is the core of our training process. We load distill GPT-2, a smaller model with 82M parameters that's suitable for T4 GPUs. We configure the tokenizer, ensure it has padding token. We load the model with float 32 precision to avoid potential issues with mixed precision. We apply low rank adaptation using PEFT. We set R4 for the rank of LoRa matrices. We use a dropout of 0.05. We prepare and tokenize the dataset, then configure the training arguments for one training epoch and batch size of 4 with gradient accommodation of 4. We initialize the trainer and start the training process and save the fine-tuned model in tokenizer. The export to OLlama function prepares a fine-tuned model to use with OLlama. The setup OLlama and inference function provides instructions for using the exported model. It shows the command to create an OLlama model from the model file. The main function orchestrates the entire process. It calls fine-tune model to train the model. It calls export to OLlama to prepare the model for OLlama, and calls setup OLlama and inference to provide usage instructions. In this walkthrough, we build a specialized mental health chatbot using fine-tuned language models. We explore how to adapt a pre-trained model for the sensitive domain of mental health support. We start by installing the necessary libraries. We set up the logging configuration for the training process. Info level logging to capture important information, a format that includes timestamp and log level, both file and console handlers to save logs and display them during execution. Proper logging is crucial for monitoring the training process and debugging. The config dictionary centralizes all the parameters for our training process. We are using Microsoft V3 Mini 4K Instruct as a base model. We specify path for dataset, output directory, and logs. We set a maximum sequence length of 1024 tokens. We configure training parameters like batch size, learning rate, and epoch. We include settings for gradient accommodation and checkpointing. We add paths for safety evaluation prompt. We set random seeds for both PyTorch and NumPy to ensure reproducibility. The mental health dataset class handles loading and processing our training data. The init method initializes the class with dataset part, tokenizer, and maximum sequence length. The load and prepare data method loads the dataset from CSV or JSON. The tokenize function method handles the conversion of text to token IDs with appropriate padding and truncation. The safety evaluator class is a critical component for ensuring a mental health chatbot responds appropriately to sensitive situations. The init method initializes the evaluator with the model, tokenizer, and path to safety prompt. The load safety prompt method loads test cases from JSON file to which provides if the file isn't found. And the evaluate method tests the model with each safety prompt. The train mental health chatbot function orchestrates the entire training process. It initializes Monby for experiment tracking. It loads the model and tokenizer, which is V3 Mini 4K Instruct. It prepares the dataset using our mental health dataset class. It configures training arguments. It initializes the trainer with a model, dataset, and training arguments. It runs the training process and saves the final model. It performs safety evaluation on trained model and saves the result. The create safety prompt file function generates a JSON file with test cases for evaluating the model safety. It defines prompt across several critical categories. The create example dataset function generates a synthetic dataset for demonstration purposes. It defines a small set of example conversation between user and therapist. The test model function evaluates the fine-tuned model with sample prompts. The main execution block orchestrates the entire process. It creates a safety prompt file and example dataset. It trains the mental health chatbot. It tests the fine-tuned model and it logs the completion of the process.